welcome back everybody. We'll be talking some more about momentum today, having some more practice. Before we get to that though, you should know that over the weekend, I got something that I've wanted for a long time.
Okay.
Yes. Yes.
Another kid.
No. Good guess though. It is the limited edition special 4th printing of Webster's Thesaurus. And I opened it up, and the pages were completely blank. I know, right? I had absolutely no words to describe how angry I was. This class is going to be filled with stuff that you're not going to expect. So why is it that elevator jokes are always well received? Why do elevator jokes always end up being well received?
They're always let down. They're always let down. They never
Good
let
guess.
down.
They're always top level.
That's the
There's some good guesses here. The reason they're so popular is because they work on so many different levels.
Oh my god!
That wasn't bad.
No, it was.
At least I didn't spend 3 minutes building it up like the first one.
I mean, we all thought you were serious, and we were all excited for you. And then as soon as you said it, started, like, talking more about it, I realized, okay, it's turning into one.
The first
thing
thing
Yeah.
says in this class is always a joke.
I know, but, like, we were all like, oh my god, he's having another kid. And then he just...
Having another kid.
I hope he did. You're the one with the dumb responses and jokes.
All right.
I can't tell if Dylan's looking at me or not.
So, momentum. A little bit about what's coming here. So there is going to be some time that you will have in class to work on your egg projects.
Oh my gosh!
That is going.
What does that do?
That is due Wednesday, April 21st.
Oh, you scared me. I thought you were just saying it today. I was about to crap myself.
Oh, please don't do that.
I was going to do it.
Please don't do that.
So, yeah, the time that you're going to have to work on your egg drop project is this Friday. This Friday. Bring your stuff in to work on your egg drop project. Tomorrow,
Can I just hold it in my mouth and jump?
as tempting as that would be, for the purposes of the camera being on, I have to say no.
Is it okay for instead of my egg drop, I don't actually drop an egg, but I just throw Andrew off the top of the roof of the ML school?
Yeah, no, I like that idea.
That's the wrong unit. That's projectile
No,
motion.
yeah, my potential and kinetic energy. I need to fulfill my potential.
Okay. So in terms of what we're going to do today, we are going to do some practice with momentum and impulse. And in order to demonstrate that, I don't remember if I've shown you guys this before.
Oh, no.
Have I pulled this out? No?
Hit me.
Okay.
I hope Mr. Dr. Dentist
That would figure, wouldn't it?
They're real rocks.
So yeah,
Hit me.
this is...
It's a genuine RPG.
Class, everybody.
I got this. It was probably, I don't know. I must have been 4th, 5th grade. It's probably one of my absolute favorite Christmas presents ever.
Dude, it's
Yeah.
in such good condition.
And it is. It
I
is.
literally lost
That
the.
looks so cool.
I lost the missiles to my Nerf RPG in like 3 months.
Oh, really? The cool thing too about these kinds of things is they made them with some power back then. And let's just see if it still works here.
Oh my god.
I suppose it would help if I actually charged it up. It's a little finicky. Alright, let's just see here.
Oh, no.
Yeah, no.
Oh, let's see how far it goes.
I'll aim over in this direction.
Just right after you.
Oh my god!
Yeah.
What? Is that why you said no?
No to what?
To hitting me.
Yeah, it says very clearly, do not fire at people or animals. So,
Dude, I would 100% shoot at my cat.
Still fire at him.
thanks.
Cat would be blown to pieces. No, my cat would jump up in the air and go.
Okay. Now, while I'm not gonna shoot any of you guys, I am going to allow somebody to shoot me. So who wants to be that person?
To shoot you?
I saw Alana and Xavier, and if I'm a little disturbed at how quickly those hands went up. Okay, so here's the question. This has to have something to do with momentum. So I'm going to be standing on this skateboard, and here's my question to you. You saw how quickly the missile came off of the rocket launcher here. So the question is, if I'm just standing on top of the skateboard when I'm shot, is there enough momentum in this that you think it'll start making me roll backwards?
Yes.
If
We
you
are.
don't fall off, yeah.
Yeah? So how many vote yes, I will at least start moving backwards a little bit. Okay.
Actually,
So,
I don't know. I
Alana,
think your
come on
body
down.
might just take that. How good are the bearings?
All right. So
Are they
you can hold it either like this or like this. Just, don't let it recoil into your face.
the glass?
But yeah, there's the trigger. I'll give you some more instructions in a little bit. Why don't you stand just under the ledge there? All right. So here are the directions now. This is on a bit of an incline, so I gotta. Okay. When you shoot me, do not shoot below here, and do not shoot above here. I got caught in the throat a year or two ago, and it wasn't the same for a while.
Do you have a cup on?
No, I don't. That's why the instructions are there. All right, whenever you're ready.
Wait, do I gotta do this?
Nope, it's all set for you. Go ahead.
You didn't move!
I didn't move at all, did I?
Do it again.
You absorbed
So,
it.
Lana, can you pick up the missile and just hand it to me real quick?
Why did you move?
Because, remember, momentum is mass times velocity. Even though this is coming out of that launcher very quickly, it is extremely light. I mean, it's just foam. There's not enough momentum in it for me to even get over the friction of the wheels and start moving off to the left.
So let's hollow this.
I'm disappointed.
I know, I'm sorry. Round of applause for Alana. Well done. Thank you for not shooting me where I
Cut the bottom off. Take the water
you
out.
wouldn't.
What if we hit his
All right,
hands?
who is the second one? Xavier, I think. All right.
Well, if we hit his hands, would it be
What?
different?
Can you what after 1-0? No, you can't put lead
Does
into one.
does it matter where we hit you?
Yes.
Like if you're mad, you can move back.
It was clearly in the directions not to hit me below the belt. Xavier, come on up.
As you point.
So we're going to go ahead and do this again just to be sure the first one wasn't, a fluke. And just as a reminder, make sure that you hit me somewhere between here and here. Once again, I did not move. So,
You got a diamond chest plate.
Yeah, he's gonna
thank you, Xavier. Well done. At the end of class, if we've got time, I'll let anybody else who wants to shoot this have a chance. So, you can find these on eBay. A year or two ago, somebody really thought it was interesting, so they looked it up, and they're like $200, $300 now or something. But yeah, you're not going to find this kind of power anywhere today in a toy store.
I don't know. My Nerf one from the early 2000s.
400 now?
Yeah.
Oh my gosh.
Oh, you have to get one.
Yours is in really good condition, too.
Yeah, I took care of my stuff.
Yeah,
Okay.
I think
Most
all
kids
of
don't do that. Most kids just wreck everything.
That is very true. Or like put everything in their mouth for no reason.
Okay.
My little brother puts his napkin in his mouth.
So let's take a look at some momentum stuff here. When we practice, here is the best thing that you can do as we go through these problems. If you remember when we first took notes, we had all the little shortcuts, and those are just fine if you can remember them. But it seems like some people are just kind of, there's too much to try and remember there. If you start here, you will always land on the right equation, because those shortcuts that I showed you guys on the board naturally flow out of this equation if you just carry everything through. Because a lot of times, one of the situations was both objects start from rest. So then basically the whole left side goes away, and you end up with the equation we eventually got to in the notes on that day. But my advice to you, and advice to myself if I were in your shoes, would be just to start here and let the equations work themselves out, and be careful to, make sure you have everything labeled correctly. As long as you do that, this will carry you to every single solution, as you'll see here. So before we get into that, I just want to show you original momentum equals final momentum. It's one thing to say it, it's another thing to see it. So let's just take a look here. You guys have seen this before.
I love that. Yeah. Newton's balls.
Look. It's one of the pages from my thesaurus.
Let's tell you what it is. It's Newton's balls. Why are there 5 of them?
Nice.
He's an experiment. We'll kick it up.
All right.
Chernobyl.
Oh, that's so perfect for the folks at home. You're welcome.
Imagine.
Okay.
Newton's balls. Balls in their
Okay. So what do you suppose happens if I pull back one of these marbles in this way? What's going to happen after the collision? Yeah, one from the other side is probably going to go. Let's just check to be sure. Look at that. This isn't quite as perfect. They call it Newton's Cradle. It's not as perfect as some of them I've seen. One of the marbles here is off-center a little bit, and it's hard to figure out how to fix that because they welded the thing in there. But I'm going to figure out a way to do that so it does its thing for longer. So what happens if I pull 2 back? Now what? 2 are going to go. And the reason for that is because of the conservation of momentum. If you start with 2 marbles pulled back going this way, you have to end with 2 marbles going that way. What about 3?
It's gonna go 3, and then one in the middle is gonna go on both sides.
Yeah, very good. You guys know your Newton's Cradle. Again, it's conservation of momentum. If you don't know this, this doesn't make any sense. You know?
What is the world's biggest ball?
I don't know.
We have to look that up.
You'll have to look that up. And again, we can do this with 4 as well, and the exact same thing happens. Because momentum has to be conserved all the way through. You start with 4 going this way, you got to end with 4 going that way. And you can see it's getting messed up here because it's not completely perfect. And the same thing goes if, maybe we do something like this. If we have 2 marbles going back in this direction, then momentum has to be conserved that way. And you should see nothing in the middle really happening.
Dude,
Just the 2 bouncing back.
that's actually nuts.
There's a Mythbusters on it.
Newton's
On
balls?
Newton's Cradle.
Oh,
Same thing if we would do 2. Momentum must be conserved. Now it's interesting to note when this is happening, the 2, it's not like the energy is going through and then bouncing back. What's actually happening is the energy from these 2 right here goes through and is transferred to these 2. So it's not like the energy is being rejected. It's just being transferred from one side to the other. And if you make it big enough, stuff happens. Like, I wonder if I just pull this back further and the other one just a little bit, you can see what I'm talking about here. Yeah, so the energy is going through. It's not like the one with the big amplitude is always going back further. That energy got transferred through to these, and then it came back in the other direction. So yeah, you could do this all day. At least I could do this all day.
There's one they use wrecking balls.
Oh, really?
Wow.
Oh, nice.
That's cool.
I'll have to. It depends on what season. I only have like the early couple seasons on DVD here. So
whatever happened to Catch a Predator?
That'll be at the end of the year, right? Are you serious?
yeah, we can do that.
Super Mario.
Keegan.
Yeah.
One day, and I'm not going to tell you when it is, but when you walk in class, I'm going to be sitting on that stool. I'm going to say, Keegan, have a seat here. What do you think you're doing here today, sir?
I just came here to hang out, do business.
Have a couple drinks.
Yeah,
Tell me.
we're not going to take that conversation further. Not with the camera rolling.
Alright, big
Okay,
nasty lover.
so
5544.
we're going to do some practice problems here. Who needs a blank piece of paper to do that? We're going to do some practice problems. If you need a blank piece of paper, I'll get that to you right now.
No, the guy with the snapback who was posting the snapback.
What about the dude who parked his Corvette in their back lawn?
My favorite is still John Duvet, the guy that
Oh yeah.
Oh, I need one.
What about the dude who pulled
Goes
up?
in for a huge hug and just walks away.
Yeah, that's the guy. He goes, I want a hug, and then she goes, I don't know, and then his head comes out. Hey, booby.
Oh yeah, he did say that. The dude who
No, he's
showed
like,
up with pizza.
In my entire professional career, I've never had someone make me this offer.
I swear to God, I wasn't even trying to beg around. I thought they would use the
The dude who pulled up with pizza, condoms, and like hard lemonade.
God, it was so cool.
I just came here to have some drinks.
Oh, you're
Hang out.
special night.
All right.
I'm just gonna kick it.
So this is the ultimate battle in geometry. Who will come out on top? The rectangle or the triangle?
Triangle.
We will find out.
It's like a ramp.
We're going to start with these two objects encountering each other in an elastic collision. That's the bouncy kind. We'll do the inelastic at the end and see who comes out on top there. All right. Here is our setup then. So we've got the rectangle moving to the right at 10 meters per second. The triangle to the left at 9. Eventually, they collide in a massive mathematical collision. And after that collision, the triangle moves off to the right at 12 meters per second. And the rectangle off to the left at 7. So, using just this information, I would like you to tell me how heavy the triangle is.
Oh, I know.
Yes.
I saw this video of this dude who like modded GTA. And he put a ramp at the front of the semi truck and drove in incoming traffic. This is what that reminds me of, because everything was just like launched off the top of
Right.
the car.
Nice. If anybody's unsure where to start, start here. You got your formula sheets too, those should help. So again, this is a bouncy collision. It is elastic. They are bouncing off of each other.
LSETR.
If you dig a 6 feet hole, how deep is that hole? About 20 feet. A carrot? don't know nothing about it here.
Still my favorite. Still my favorite of all time is that. Hey, you slapped us. What'd you call me? You slapped us. He doesn't like Obama because he's like, talk about things behind his beaches.
Thank you. I like when you're depressed on the podcast.
Oh,
Like,
he just wasn't saying
it's like, you don't do something wrong. I'll kill myself.
I remember that was heartbreaking. Don't say that. Yeah,
I'm gonna do it.
No, I also love.
Did you say you were gone when I collected it?
He was hanging out with that one dude, that guy's name, stutter guy.
Spit it out.
Yeah, it's like stutter guy.
Like, just use words. Spit it out.
Yes, I went to the University of.
Spit it out.
He also asked out that one girl from the show. He said, "Hey, you must focus some trains." She's like,
Have you seen him go wig shopping?
"No,
I will mention that a lot of folks in the first physics class that did this made the same mistake. So be very careful as you're handling this problem. That's all I'll say.
I think I did it right, but I could. No, I didn't. Okay, I don't think I
LSTER.
Carrot.
Man, I don't know nothing about a carrot.
It's a carrot.
It's a carrot.
Finish up in the next minute or so. I'm going to come around just to see where you're at.
I want to know. Okay, so at least I'm like somewhat in the dark. Yeah.
There's just one thing that...
Carrot. I don't know nothing about carrot.
No, I think the stairs are blank for like 15 seconds.
Oh, well, this is
Same.
So, the momentum equations are...
I like those wrestling videos.
Because this is elastic.
Oh.
I asked you.
What you call me?
With the clay math masters.
Well, let me see your sheet. I got it wrong. Oh, I just want to see it. Oh my god, oh my god!
Beetlejuice wearing a Clay Matthews jersey.
Oh.
But I got it wrong.
Imagine having an idea of where to start. Oh, Mr. Hathaway.
Yes.
I did all the missing assignments.
Oh, good. Make sure to get those to me sometime. Okay. So, did anybody end up with 24.3 kilograms? Okay. So, that's good. 24.3 is the correct answer. There's a lot of little things that you have to remember as you go forward in order to end up with that solution. That is the correct one.
It was really hard.
Here's the main thing. So, when this collision happens, we're moving in two different directions. You have to take those directions into account. So you have to set one direction equal to positive and one direction equal to negative. So for me, I usually set to the right positive and to the left negative. So that would mean here that this 7 is negative. And it means that this 9 would be negative.
Oh, you missed that, Keegan?
So that's the big thing with this. So let's carry that through and see how we do this. So I'll just say R for rectangle here and T for triangle there. So that would be our elastic collision equation there. So we just have to plug the numbers in then. So let's go ahead and do that. So mass of the rectangle is 30. Original velocity of the rectangle is positive 10. Mass of the triangle, we don't know. Original velocity of the triangle is negative 9. So this is going to be minus 9 mt. All right, then we've got 30. And then final velocity of the rectangle is negative 7. And final velocity of the triangle is positive 12. All right. So that should be the entire big equation here. Any questions on where these numbers came from? All right. So let's just do a little bit of math and see where we land. 30 times 10 is 300. And I'm going to take this and move it to the other side. The negative will then become positive, so 9 plus 12 is going to be equal to 21. And then I'm going to shift this over to the left. 30 times negative 7 is going to be negative 210.
Then you add it.
Exactly. It switches to positive when you move it over. So, of course, 300 plus 210 is going to be 510. And we do a little bit of division. So I got 24.3 kilograms. And that would be your answer. Again, the big thing here, you got to keep your directions straight. You have to have a positive direction and a negative direction. If you chose left to be positive and right to be negative, you'd get the exact same answer. Okay. Good. The alternative way you could do this would be the impulse way that I talked a little bit about a time or two ago. So in that case, you have all the information about the rectangle here. You know the mass, you know the original velocity and the final velocity. You could find its impulse, its change in momentum. Then you could make that number the opposite. It would be, you could make that number negative if that's positive, or you'd flip it to being positive if the impulse is negative, and you could apply it to this mass. And you could use that to figure out the overall mass, and you'd get the exact same number. So again, you just use this information to find impulse, switch the sign, set it equal to this, and you'd be set to go. Now, but I think overall this is probably easier to understand. Even though we have a longer equation, it's more straightforward.
Makes sense.
Yeah. So let's change this up. We've got the same two objects doing the same two things, but now we know this mass, so that's nice. That's 24.3 kilograms. As you can probably guess, we're not going to have the same kind of collision this time. Now we are going to have an inelastic collision. So now these two objects are going to come together and they are going to stick together. And we're going to see what their velocity is after that collision. So let's just make a quick prediction here. We've got the rectangle. It's heavier, but it's moving. Actually, this isn't going to be much of a prediction because this one's heavier and it's moving faster. This one's lighter and it's moving slower. So we could probably assume that after colliding, they're going to move off in the positive direction because we know this momentum is much larger. So yeah, go ahead, solve for the final velocity of the combined wreckage, and see what you can do. While you're doing that, I'll pass out worksheet number 3. That will be due on Thursday. Tomorrow is a Mythbusters Day.
It's like this dude with like green hair and stuff.
Yeah, no, sadly not, yeah.
But is that movie weird?
It's alright. My mom lives in that movie.
I've never seen it.
Yep.
I wonder if they really met Uzi and Beetlejuice. Is there a picture of it?
Well, it was like 5'1".
I was gonna say, for Beetlejuice is like 3 foot.
No, Uzi was just standing on top of his money, that's why. Yeah, that's what he says in his song. Stand on top of my money,
I'm 6'10". I'm taller than Shaq.
it's real. Dude, they actually met, that's lit.
Two kings. Might be my new background.
Have you ever seen a drawn tomato truck?
Yeah, that's lit. I can't wait to get my Civic.
60 seconds. Finish up.
Dude, I need to like email the dealership or something.
Yeah, I'm
The music could be too loud for you to When you date a physicist. You're too busy playing little sports
Oh, good point.
Oh, yeah.
The answer, saw a lot of interesting answers to that.
Well, yeah, what was the answer?
The answer was about 1 in 40,000. So yeah, because you generally an average person sneezes about 4 times a day. So if you do the math,
Shut up. I tried to do math. It was so wrong.
oh, that's okay.
Who got the extra credit?
I don't remember from this class. I did the same question in all the classes, but if you find 2 extra points in your extra credit column, then you got close enough to get those points. So it was a fun question though. So yeah, let's take a look at this, and then we'll call it a day. So this is an inelastic collision. So we begin with the same equation. But the whole right side of the equation is going to be different from the left, because after they collide, they stick together. Listen up, guys. Keep it down, please. They stick together and they stay together, which means you have a combination of the 2 masses. And then they just have one combined velocity afterwards. So, the good part about this is we know all of these numbers except that last velocity. So we just have to do a little bit of division. So let's just put those numbers in and do that. So again, mass of the rectangle is 30. Original velocity is going to be 10. And then we've got 24.3 kilograms times a velocity of -9. And that's this side of the equation. So then we have to divide that by the addition of both masses in order to get that final velocity. And all we're doing is dividing both sides by that sum. So that's going to be equal to the velocity of the rectangle and the triangle. And if you plug all those numbers into your calculator, what pops out? 1.5 is right on the money. And that is a positive number, right? Yes, and that's exactly what we were expecting, because this is the bigger mass and it's moving faster, so it makes sense that after the collision, the wreckage would move off in the direction it was originally going. So yeah. All right, again, that worksheet is not due until Thursday, and we've got a Mythbusters Day tomorrow, so look forward to that.